Okay, today we're going to talk about exponent rules. We've been dealing with variables and numbers and letters all put together, and you have talked about exponents in the past. Things like 3 raised to the second power. It indicates that you're taking 3, the base, and multiplying it by itself 2 times based on the exponent or the power, and you say 3 times 3 equals 9, and that is how you simplify that. Okay? Now, today we're going to add in letters, because we all love letters in algebra. We are going to use the letter A as our base. There. Base. You should be taking notes on this. This needs to go into your notebook. And then now we're also going to label, if I give you a to the n power, n is going to be the, n and m are going to be the exponents that I'm going to use. I know that we usually put numbers, but for rules we're going to put letters to show what would happen to the numbers if we apply the rules. So I have a to the nth power, so let's label that as well in our notes, and we're going to call it a power or slash exponent. Okay, so our base is the a, so when I say the word base, we're talking about the variable. We're not talking about a number in front, like if we have 3a to the nth power. The exponent only relates to the a, which is the base, and the 3 is just our coefficient, something we've dealt with for a while now, but right today we're mainly going to be focusing on our base, which is our variable, and our power or exponent that is the n in this one. So get that in your notes. And first we're going to talk about what we call the product rule. One of the hints I'm going to give you is it's really helpful. After we do these notes, I'm going to have you get a card and put all of your rules on there, showing them the rules and what happens to the exponents whenever you apply the rule, so that you can use that to help you get better at using these rules. Okay, the product rule, what does product mean to us? It means multiplication. So that means that I have variables with exponents, let's say a to the n, and it is being multiplied by a to the m. So you can see they have different exponents or powers, but they have the same base. So these exponent rules that we're doing here, they only work if you have the same base. They must have the same base. That's something I'm going to put on here. Must have the same base. That is really important. If they don't have the same base, then this rule doesn't work. So if I have a to the n times a to the m, the rule tells me, all I do is I say a to the n plus m. I add the two exponents together. Now, let's look at why that works. Okay? So we're going to go off of what you used to do when you expanded exponents. We're going to look at this. We're going to put a couple of numbers in here, and then we're going to expand exponents. Okay? So I'm still going to use the same base, a. And I'm going to change my n to a 2. And I'm going to say a to the 2 times a to the third power. So a raised to the second power and a raised to the third power. If I just apply the rule, in which you know I don't like to just apply rules, I like to know why the rule works. But if I just apply the rule, the base is the same, and I take 2 and I add it to 3. And so I'm going to get a to the 5th. So I just took 2 plus 3 and I got 5. So I have a to the 5th. So a to the 2nd times a to the 3rd equals a to the 5th. Now let's expand this and see why it works. Are you ready? So if I have a squared, that means I have a times a, right there. If I have a to the third, that means I have a times a times a, right? So if I look at these expanded, how many a's do I have? 1, 2, 3, 4, 5. That is how I get to the fifth power. Now, do we want to expand every time? Do we want to have to say a to the 13th times a to the 12th and have to count out how many we have? No, we want to do the simple trick of, can we see here still? Okay, we want to be able to say if I've got a to the 10th times a to the 23rd. That's a lot of a's to have to put together. But I can use that exponent rule, a to the 10 plus 23, which equals a to the 33rd, right? So these rules, I don't want you to forget why they work. I don't want you to forget what operation is actually going on. But this right here saves me the time of having to expand all that out and figure out how many a's I have there. So the rule is great to help us, but we still have to know why it works. Next, we're going to do some practice on these, and then we're going to move to the quotient rule. And I bet if you think about what the word quotient means, then you'll know what we're going to do with the quotient rule, what it has to do with.